All right, let's get to business. I think I'll say good morning, afternoon, or evening, depending on whichever part of the world coordinate system you are. It's really excited. I'm really excited, and it's good to have you here. All right. I know our numbers are not so much, but yeah, I believe that what we are going to take out of this meeting will be highly valuable. So maybe I'll start with a story. I'll start with a story. So I shared this story with a couple of persons, and when I shared this story with them, they saw they saw the essence of it. So the story it goes this way: the purpose why we have simple opportunities in the future. All right, we want to equip each and every one of us, and the best way to equip us is, through moments and sections like this. All right, yeah, through simple sections like this. That's the best way. It has been widely carried by most motivational speaker that the only way to transform a man is to is through two avenues or tools: who they meet or the books they read. And I believe so much that yeah, when you merge both together, it can actually amplify the value, and that's what we are trying to achieve within this community. So please do well to work with us as our target is simple. Our target is purely to achieve that goal. So this is my story. I transitioned from mechanical engineering. Um, After I completed it in 2008, I began my transition, or I got desperate that look, I really want to be in the oil and gas. I don't want to continue my experience with a power plant generating company, a power generating company. My desire has always been oil and gas, but for some reason, like some of you, when I was filling my jam form, I was actually constrained that it must be mechanical because mechanical is broad. That was the excuse. That was the reason. That was what they told me. That mechanical is broad. And back then, imagine they started telling me that look, the petroleum industry is saturated. There are too many petrochemical engineers out there. Oil will soon finish and all of that. But yeah, it looks like my passion has always been petroleum. So I was obedient to that gospel, and I read mechanical and did very well. And I said, okay, it's time for me to transition. So I didn't have any experience in petroleum, and I went ahead to commence a master's course that, first of all, I couldn't get the desired program because that I wanted, because that program requires at least 5 years experience from an operator, from an EMP company. So I couldn't get into that. I got into oil and gas engineering. And after the first semester, my performance was adjudged outstanding. And that gave me the opportunity that, look, you can now switch, but you pay the difference in tuition. So I went ahead to make that switch to petroleum production. And I met a couple of friends. One of them had worked in Slumberger, had over 5 years experience. The other had worked with them, Snepco. So the one with Slumberger was a wireline engineer. The one with Snepco worked with their production operations team. So most of the things I was hearing when I switched during the second semester, they were really strange. For example, I was hearing lots of things like rel pen, and I would be like, what kind of jargon is this? What are these people saying now? And when someone asks a question and the person is using the word rel pen, I'll be itching my brain. The lecturer will go ahead explaining, and then I will ask my own question to bring them back, or tap someone by the side that this weapon, what is it all about? Yeah, so there were certain technologies I really struggled with, but yeah, the straw really hits the camel's back when we went out on the dinner party. So there was this new company that just came into our party, and they were organizing more like an evening dinner, stroke career fair, supreme, superior energy. Yeah, superior energy. I had superior spirit energy. Yeah, 'cause I went to go, but yeah, we went for this um, evening dinner and career fair. And while we were there, we were just around the table, and a manager from that company approached us, said he has been observing us that we look like we are students. We said yes, we are actually students studying with the Rotterdam University. He said, oh, fantastic. Now why are we here? So we explained to him that we're about wrapping up our program. That this one, okay. So the one from SNEPCO, he was actually he went ahead with oil and gas engineering, while the one from SLB and myself we switched from oil and gas to petroleum production. So the man was like, "Oh, fantastic! Good. You have SLB experience. You have SNEPCO, Porter experience. Good. Me, I didn't have any experience, but I was just eager to get in as well. So he threw a question. He said, okay, that he can make that whatever response we give him now, that is right, he will just direct us to go meet the HR. All right, that they have actually bought a brownfield, a mature field. And then that particular field, there are certain operations that they cannot do on it. So what they need to do on it is called snubbing. They need to actually intervene on the wells um, via a method we call snubbing operation. And he threw the question at us that if any of us can explain what snubbing operation is, then he will direct us to go meet the HR. Yeah, with a referral from him. And as a local man that I am, coming from the village, the only thing I know about snubbing is when you're not talking to someone. So I looked at my friends who are working with SLB, who took study leave, the one from SLB and the one from SNEP. I looked at them. I thought that, oh, this would just be an easy. I mean, I was happy that, yeah, if they get it, I mean, that means one of us or two among the three of us have gotten. I was so excited. I thought this would be an easy thing. Those other people were also looking at me. That's when I knew that there's trouble, that we've not done anything regarding snubbing. Regarding snubbing, that unfortunately we don't do. I said, okay, okay. Unfortunately, that's just it. Thank you so much. Thank you. Wishing you the best of, and he moved on. And while I was at that table, I knew that this was it. That this was it. This is the moment that will never pass me again. Yeah, I will meet a question in petroleum engineering and I will not know what to say. Absolutely, I have never heard the word snobbing. And I believe a lot of you here also um, is coming to you as a new word. Maybe you would have looked it up online. Now, what is snubbing operation? And if you're unfortunate to get into the urban dictionary, or now that some slangs from Africa is getting into Oxford Dictionary, you might even see the African meaning. But please don't take it to an interview anyway. So, so that was it. So I told myself that no, 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 no. That it's time to change the way I do things. And in order to revive it, I had to specifically ensure that, yeah, before the end of my program, and I pick up a petroleum engineering book and I'm going to understand that book from cover to cover. And I'm going to discuss that book, if possible, daily or weekly with an expert. And I was gracious enough to meet well operations post where I did internship with Fairfield. And yeah, although they didn't have my time because Fairfield bought that field from Apache, and Apache have operated that field for about 20 something years, and Apache bought it from Shell, and Shell operated it for over 30 something years. So it's a really mature field. So they were just squeezing the last drop of oil from it. Most of the wells have been shut in. Most of the other wells were already lined up for abandonment. The company was also, at that time, I never understood because most of them were going for certain training that had to do with decommissioning. And there were a lot of bores around decommissioning and all of that. So eventually, yeah, let me leave that part and just explain that, yeah, I met these guys, wonderful guys who have very sound and solid experience from BP across several service companies, and now they are with Fairfield Energy. So they gave me they gave me an original manuscript from Jonathan Bellaby on well completion design. And I started reading that manuscript while supporting them in their operations. So certain times they need data, if they need certain reviews to be done, if they need certain analysis, I'll just do it, pass to them. They bring me into meetings and all of that. When I was too busy. So the good thing was that they gave me that manuscript and I said, okay, I have to saw the original book, the book that Jonathan Bellaby had written on web completion design. And I picked up that book and I started reading it. And every time I go to work, I had questions to ask. And often, even before I arrive at work or even in the evening, I would just chat to them up. Then, of course, Skype was there. There were lots of other tools that are available. Then I'll just send them that please. So tomorrow at work I'll need to learn more on this. When I'm reading it, it's really exciting, but I'm getting confused around this area. And believe me, when I go back to work and I ask them a question that has to do with A, these men will pause whatever they are doing and they will explain like from B to Z. And it was like they were dishing the entirety of their experience to me, to me. And I never went to the field to do a completions, but that gave me so much boldness that if I meet anyone from any service company, the person cannot discuss completion and I will not have a contribution. And there is also no way that I cannot run a training for any EMP company on web completion design. Because mechanically I understand the stress analysis part, the design aspects, but the other peculiarities that makes web completion an act, those were the things I needed to learn from them and some of the jargons. And then some of the other things that come into it that actually affect the reason why we complete wells the way that we complete them because of maybe reservoir properties and other things. So I'm sharing this just to enable each and every one of us to know that the purpose of this section is for us to pick information. You don't know where you make use of that information. You don't know the avenue. You don't know the opportunity you will meet. All the interviews I've gone for, there's always a question. There's always a technical. I mean, we all here, what we are doing is going to be mostly technical. So yeah, if you're in the technical field, you're going to always face that moment when you'll be in front of a technical panel or you'll be across um, a virtual channel with them, a panel, and then they'll have to throw you some technical questions. Take for example, recently I was thrown questions that have to do with things that could make oil water contact. Okay, the kind of data that you can get from a petrophysics, the kind of data you can get from a reservoir engineer, the kind of data you can get from a geologist, how you put all of those data to make informed decisions. Okay, so one of the outcomes that I told them was the hydrocarbon distribution plot. They said, okay, someone picked up that question and looked at it very well and said, for this hydrocarbon distribution plot, something can make the oil water contact not to be flat, not to be linear, not to be straight across. what are the factors, what are the things that could make it. And that's where you need to start you put on your petroleum engineering hat and you start answering the person. So we looked at the fact that okay, interface faults can actually affect it. That can actually bring in a major influence. Stratigraphic influences can come in geologically, and then also, of course, um, we can look at also the possibility that if we have localized fingering, right, water frame fingering as a result of mobility ratio challenges. So the person picked it up from there. The person say, fantastic. Now you've mentioned mobility ratio. What happens if the mobility ratio is greater than one? What could be the impact? It was basically asking me the thing that I've answered to see if I know it very well. So I needed to like sit back and look at mobility ratio because mobility ratio you must understand whether it's the ratio, you must know it very well. Is it really the ratio of the displacing over the displaced, or is it the displaced over the displacing? Because a lot of people get it from there. And then you now start analyzing, um, looking at the variables that are in the equation. And basically you want to be able to settle with the viscosity, that the viscosity of the oil or the viscosity of the water, compare them. Because basically, if we have pulled our well with a high drawdown and then we have a system where the viscosity and disparity is high, then we can actually be able to shake things up and then we will not be able to have that unified contact. Okay, so I think that has been a beautiful story while I was awaiting for folks to join the meeting. That's really been a beautiful story. So, ladies and gentlemen, it's my huge pleasure to welcome us to this section. This section is really going to be short and simple. In this section, first of all, we want to get ourselves introduced to what I would call the integrated production system. For me, that would be like a starting point. Okay. Before we really dive into anything that we need to do, we need to be able to see the entirety of the production system, appreciate it, and then when we have appreciated it, yeah, we can now make um, further journey into it. That's when we can now pick each aspect of it and now be able to say, okay, can we pick an aspect and then fully go into it, like do a full deep dive into that particular aspect to see what it is all about. Yeah, so that's basically what we are going to be doing today. We are going to pick an aspect of we are going to pick an aspect of the integrated we are going to pick the integrated production system, and then we are going to actually do a review over it. And when we have reviewed it effectively, reviewed also the life cycle, discuss the life cycle, um, I believe from there we can now be able to pick other discussion moving forward in our subsequent meetings. We can be able to pick other discussions, yeah, from it. So I think first of all, welcome everyone to today's meeting. I'll spend the next 15 minutes discussing or sharing with us the concept of integrated production system, why it is essential. While as we are here now, we should not see ourselves that um, we should not see ourselves like we are the ones that are going to do everything. All right, we are not the ones that will do everything in the E&P companies. No, 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 we are not the ones. There are other people that are going to support us. We are not the ones doing everything. So oftentimes the folks that are very technical, they think, yeah, that we are the ones doing everything. But that's not true. That's not true. Please confirm you can see my screen.
Not yet. I can't see it from my end. Okay, it's coming up. Yeah.
All right, perfect. So I think I've taken quite some time to share with us those discussions. So let's move straight into the business for today. All right. So we'll begin first with the asset life cycle. Now, the reason why I want to introduce us to this asset life cycle is that I've discussed it with a lot of fresh graduates, and I've seen them struggle. All right, across it. I'll have a slide that will summarize it. This one might look a little bit complex, but I'll have a slide that summarizes it. All right. So first of all, what we are trying to showcase here is to help us understand that when it comes to asset management, it follows an integrated approach. It actually follows a systematic and integrated approach. So what that entails is that there is a well thought out process that basically requires people from different backgrounds working together to deliver value. And of course, the E&P company, their overarching value is optimization of production and cash flow. And then, because they have to work under the confines of regulators, the overarching value of or yeah, the overarching objective of regulators is the maximization of recovery. So regulators want to ensure that that whatever the E&P company is doing does not endanger, all right, or destroy the economic life cycle of the asset. So what that means is this: when you do a studies and you take it to the operators and you've told them, okay, that I have this well, I have this well, I have this well, I'll be producing at this rate, I'll be doing this. One thing they're going to throw at you is what is the ultimate recovery? Now we know theoretically, we know that certain numbers have been put up around ultimate recovery. Certain numbers have been put around it, depending on the drive mechanisms, then depending on other factors. So drive mechanism, of course, is just one aspect, but is also based on the existing technology that is being used. So whether you are producing that well natural flowing or whether you are using artificial lift, all of them are under the primary recovery. Or you are doing water flooding, or whether you are doing injection, whether water or gas injection, those will fall under secondary. And then if you are doing the enhanced recovery, yeah, which may involve chemical, thermal, gas, and so on and so forth. So, yeah. So they want to know what is your recovery based on the technology, based on the technical, the functional requirements, based on the existing constraint, all right, the peculiarities of that reservoir, of that field, of that asset. What is the ultimate recovery? The reason is because, and I've noticed that their interest is usually that they are not happy when the recovery value you are telling them is less than 30. They're usually not happy because theoretically, it's been known that, in the Niger Delta, that our recovery value, especially for water-driven reservoirs or combination-driven reservoirs that have a dominant aquifer, that you get a recovery around that 30. So if you're telling them anything less than that, you see the worries in their eyes. And that worries will be so glaring. And you want to pay attention to that. So it's purely an integrated approach. It means that it's not just a single team that's going to deliver this. Several teams are going to be involved. All right. So first, you are going to be requiring resources. These resources, you can actually put them into two branches. You can call them either people and data. Now, that actually forms the heart of asset management, the people, the data. Because the people can only make decision as good as the data is, because they are supposed to make data driven decision and not make decisions based on gut feeling. And then the data itself cannot generate decision, cannot make decision, cannot write proposal. Someone needs to interpret it, someone needs to document, someone needs to create the program for the proposal, and that becomes the program and do all of the analysis. Yeah. So that means that we are looking at them, for example, we are looking at the exploration, which may entail the geophysics, the geology aspects. We are looking at them, the geoscience, which is where purely we are looking at how do you identify hydrocarbon bearing sands, characterize those sands, ensure that, yeah, we are able to understand very well the reservoir properties, right? Yeah, although that will still be within some percentage or some margin of accuracy. But yeah, we know that we cannot be exactly accurate, but also we don't want to be comprehensively wrong. And of course, we also want to, of course, do our logging, scoring if possible, and then ensure that we bring all of those data into our analysis, because it's going to actually help us in doing a lot of quantification. First of all, quantifying to justify even to investors why they should invest in that field. That look, there's a huge amount of oil in the field. And then, of course, we want to be able to also do some simulations. Or if we have, if it's a field that's already in the operate phase, we want to look at our performance data, review our performance, our production profiles, and see how well are we producing, what opportunity can we take, what intervention can we do to be able to arrest certain issues that are already existing in our assets. So we want to be able to understand, look at those profiles, make some informed decision, and then generate very insightful solution, remedial actions that can help us arrest some of the issues. These issues will be issues that have to do with high water quality, high GORO, um, I mean, flow assurance, maybe wax deposition, yeah, or issues that have to do with either maybe our THP is declining, or sand production issues that want to be able to look, or maybe issues that have to do with well integrity. Possibly we are seeing occurrence of a sustained or an annulus pressure, all right, increasing annulus pressure, and then we need to go and bleed it and monitor the annulus and all of that. So it's very pertinent. And then, of course, for our laboratories also, we want to ensure that, yeah, we have certain data that will come from PVT, that will come from our special core analysis, and we need tools to be able to do this. We need just an idea that yeah, before now, of course, there are not software solutions, and people were really doing this thing using Excel. So you can either use the analog approach, you can use the analytical approach, yeah, to be able to do all of this. And then once we put this together with our studies, then we are coming up with short-term and long-term asset management plans. All right. And all of these plans will definitely feed back into our asset optimization goal. And definitely we need to put it under the confines or the constraint, the available constraint, because funds or resources are scarce. The economist comes in, and also the constraint of facility comes in as well. So facility brings in a huge costing into it, which is where you see some operators will say, okay, we don't want to own the facility. We want to produce the fluid, and then we will we will do a custody transfer of that fluid to another company, and that company will take it to sales points. Please follow my story. And then they will now they will now enter into an agreement called the Crude Handling Agreement, CHA. So that crude handling agreement, the company that is taking the responsibility that is going to actually receive crude from the other company will say, okay, they are going to give us your crude, you give it to us at this specification. They might say, okay, look, don't give it to us at any BS and W greater than 1 or greater than 5%. Anything above 5% will be penalized. I'm just using that as an example. You'll be penalized. So it's because when the crude gets um, to storage, they also don't want to subject it to, I mean, too much treatment. And they may say, look, these are the facilities we already have on ground. So this is the spec we expect from you. Anything you give us beyond outside the spec, you are going to be penalized. And then all of that will go into the contract that we form the agreement and they will agree. All right. And crude handling agreement will be somewhere around $3, about 3 point something dollar per barrel. So they will agree, and then that takes the burden of facility away from them. And then for some other companies that are developing their fields in shallow deep water or deep water, they may say, look, we don't want to go into the burden of getting or acquiring an FSO or an FPSO. What we just want is that we want to hire it, we want to lease it. And they will start thinking about whether do we go into a wet lease or do we go into a dry lease. So those are basically economic term, economic terms. And you might have heard this also because even the airline industry does the same as well. So yeah, the airline industry, most of the airlines or the planes that you see are not actually owned. For example, Air Peace or even Air might not are not the owners of those airplanes. They basically lease them. There are companies that own the airplane and they rented those airplanes to these Nigerian companies. And this is the difference. So in the wet lease, okay, or in the dry lease, all right, the person that is actually that will be the leaser, the lessee will need to be the one maintaining the plane or maintaining the facility or the equipment. So he will be responsible for maintenance of the equipment, crew. He will have his crew. He will be responsible for maintenance. Yeah, he'll be responsible for all of that, and he will still pay the cost of rental. He will pay the cost of rental. But yeah, but when you go into a wet lease, the person that is renting their equipment to you, okay, will basically provide you with almost everything that you need. So they'll be responsible for the crew that will manage it. They're responsible for maintenance of the equipment or the facility. Okay. And of course, that takes a huge burden away from you, but comes with a higher cost. Comes at a higher cost. So that also will be factored in at this point. And then you need to run your economics based on the cost of any of these models that you are using. So you bring in that cost into the petroleum economics sheet you are using and you analyze. And all you're trying to do is that you're trying to look at the cash flow, all right? Your NPV, how juicy it is, your break-even period, when will it happen? And then what will be your unit development cost? What is your unit operating cost? What is your unit technical cost? So the unit technical cost is the sum of both the unit operating and the unit development. So the unit development basically only the um, looks at only the capital expenditure aspect, which is the drilling, majorly the drilling cost that you incur as a result of developing the field. While unit operating looks at the cost you will incur operating the field. So yeah, you look at all of that and then You start working out a framework to maximize and value. So I think without them spending much time here, what I've just explained to us brings to an idea to us that everything that is happening here is not going to be done by a particular field or just one person. All right. There's going to be a team, there's going to be integration, there's going to be synergy. All right. There's going to be also support, organizational support and backing to make it happen. So during the course of this explanation, I have basically touched on a few things. But in introducing to us what the life cycle asset management basically is, all right, we might have come across this already in school that once you win a block or an asset, basically the first phase you want to go into is called the exploration phase. And in this phase, you are not generating any revenue, you're actually incurring expenditure because basically you are exploring, all right? You are exploring, you're exploring the field. So that's where you do your seismic survey, and there may be need to, yeah, although I've captured there are no wells drilled, but yeah, there may be a need to drill one or two wells, all right, to actually confirm the presence of hydrocarbon. Those wells will form the block of what we call your exploratory wells. There may be wells that you might need if that field um, proves to be viable or profitable. There may be wells that even if the field proves to be viable, you may not need anymore. You may have to just go ahead and drill new wells. So also, of course, data is limited at this stage. So, but what you are really trying to do is that you want to explore, you want to gather information about the subsurface to be able to know your next step, whether should I quit or should I go ahead. And then, of course, there are no production data to analyze because we've not started production. CapEx at this point is really not as high compared to others. All right. And then also, of course, from the management perspective, um, they want to know is there present of hydrocarbon or not. Okay, so whatever data that we've gathered at this point from seismic needs to be interpreted, from the exploratory wells also need to be interpreted. Yeah, they want to know it. Oftentimes, of course, we might depend on analog field. So if there's a field nearby that have proven hydrocarbon, we might base our judgment on that field. And then we move to the next phase that we can call the appraisal. So at this appraisal stage, this is basically when we are going to drill additional wells. We are going to target the boundary of the field. And what we are trying to do is that we want to actually delineate the extent of the reservoirs. We want to be able to also at this point gather information that will help us in quantifying, all right, first in delineating the hydrocarbon zones and then in quantifying the hydrocarbons that we have. So that means that log data will be acquired at this point also. So the data is not as much as we have when we get into other operating into the operating phase, but yeah, we are still going to acquire data. And the reason why we are acquiring data is because we want to limit or reduce or beat down or mitigate our uncertainties. We can't actually invest until we know the volume of oil that we have, until we know, and we need to know the area. All right, we need to have an idea of the area, the thickness of the sand, petrophysical information. Yeah, we need to have all of those informations as well. Porosity information, the net gross, the gross rock volume. We need to have all of those information, and this information acquired at this stage together with the DTS, the three stem test, TST. is done at this point. Also, where we prove those wells to know what their production um, viability will look like. So we put them under a test, all right, using a drill test string to be able to check how will this well perform under different choke sizes. And then, of course, we start the planning of the field, which is the feasibility studies. The feasibility studies take into account a lot of the things I've discussed earlier. The economic evaluation comes in, several constraints affect it, including the scope of recovery, not just the economics only. The scope of recovery, what we are getting out of it, affects it as well. And of course, this phase depends a lot on data. But no matter how much data we have, even the dynamic model we are going to build at this stage will not be good. That dynamic model will be improved with time because as we start acquiring production data, the model um, will be updated and recalibrated. So we move to the development phase. If the feasibility studies proves okay, and then it becomes a feasibility field development plan, we move into the detailed development. And in this development phase, this is where we begin to convert some of the wells that we have into development wells, finalize our development plan, drill more wells, infill drills, do a lot of drills. Although while we are drilling, we keep to regulatory standards. And one of the regulatory standards that we hit at us will be the well to well spacing. That is the center to center spacing, subsurface spacing of each well, because the regulators will say that look, each well needs to be spaced by about 400 meters center to center, subsurface, which means that on surface, the wells can all start from a common cellar. But as they go down the subsurface, we will have to, when they get to the target reservoir, we will have to ensure that we give them substantial spacing. And the reason is because the regulator is interested in maximization of recovery, doesn't want any interference. Because any interference basically will endanger the life cycle of the hydrocarbon that is caught within the point of superposition. So this phase also involves a lot of capital expenditure. So the capex there is high. Imagine in Nigeria where we drill a well with an average of about 30 to $40 million for a typical straight vertical, not deviated well of about 10,000 feet. So, and you are drilling lots of it, you can imagine the cost. And then, of course, not just the drilling, the facilities and everything that have to come into play. The cost of those facilities, if pipeline is to be made through to the next party that will pick it up under your crude handling agreement, all of those facilities you need to put the cost of the pipeline construction into your plan. And then also, this is the phase where also you look at resources that you have. And you need to also put into account the fact that, yeah, how well am I going to ramp up this field? How long will my plateau be? What phases, how am I going to phase in the wells? That is bringing the wells. Because, for example, if you have 20 wells to be drilled, you can't drill 20 at a point. You have to phase them. The reason is because rigs are not readily available, number one. Number two, again, resources are not readily available. So if it's okay, we want to drill the first 7 wells this year. In the next 2 years, we are going to drill another and then another until we ramp it up and hit our plateau. So, which means also the facility guy does not need to design his facility to only accommodate the initial phase. He needs to design his facility plan is that look, our capacity is going to be a 50,000 barrels of liquids. We need to design this liquid handling capacity to that 50,000. And then, if possible, give some haulage, all right, in that design as well. We need to do a lot of risk assessment, things that can cause delay, because any delay, any schedule overrun, time overrun, cost overrun will really come back at us at this phase. Most of the things we are doing at this phase are long lead items. Long lead items are items that are not in Nigeria. Wellhead is not in Nigeria. It's not manufactured in Nigeria. You get it from abroad. The casing, they are not manufactured in Nigeria. They are coming from abroad. So if you have any vendor, it's either that vendor has it there already existing in their warehouse, or you work with your procurement department early enough to ensure that yes, those facilities, I mean those tubulars or those equipment are ordered ahead of time. And then also at this point also you are going to do your lookup to facilities. So you don't just want to drill, complete, and then leave the well. All right. You will want to hook it up to facilities. So it means that either concurrently, yeah, you are building your pipeline that will be coming towards the facility, or you are setting up the first mile operating production unit, the MOPU. And that MOPU could basically be that, yeah, you look at for a module, which is a mobile operating drilling rig, a mobile offshore drilling rig, sorry, or a mobile offshore production unit. You look for a mobile offshore drilling rig, and that drilling rig basically you convert it to a MOPU. All right, converting to a MOPU means some equipment on it, like the derrick, the drawwalk, yeah, all of those equipment you will replace them with production equipment, your separators and the rest. Yeah, together with your manifold. So you put all of that in a very confined footprint. So once we get out of that phase, the development phase is where we hit plateau, which is um, where we are going to actually want to maximize profits or revenue. So as much as possible, we want to extend this. We want to do proper WRFM, well reservoir and facility management. We want to be able to have ensure that yeah, we build conditions around our well, our reservoir, and our facility, our reservoir. Create any of these assets outside those, and also very, very diligent to ensure that yeah, during fields execution jobs, we don't go in and jump anywhere and basically have a situation where we can no longer even have an access through the well. So that's where proper risk assessment and all of that um, needs to be done. And then at this point also we are going to be dealing with a lot of issues, because when we are at that phase, other production operations challenges will start hitting our face. Things that have to do with water cut, gas production, tubing head issue, well integrity issues, several issues will start coming our way. And we want to be able to come up with smart ways of managing them so that basically we are able to extend the production life. So just for our information, our well or our tubing does not know oil, does not know water. What it knows is liquid, does not even know gas, except if it's a gas well. So if it is a well that you are aiming to produce oil, what it knows is liquid, which is why it is just there to produce liquid for you. If you are lucky enough to be far away from the oil water contact, it can give you dry oil. But when water comes, all right, water breakthrough will cause oil decline, because they will need to adjust in terms of keeping constant the liquid. They want to adjust. So as water is increasing, the oil will be reducing. Okay, the oil will be reducing, which is why that is the point also where all the engineers will be on their toes. So, and of course, this field will be operated until we hit economic limit. So economic limit now becomes a target where we know that, like I explained in the fair fit scenario, the company already knows that yeah, after that experience that they have, they don't want to go into ERP operation. And Gulf, I mean the UK continental shelf is already mature, and a lot of assets will start looking for decommissioning jobs. So they were already planning to become a decommissioning company, but I did not know as an intern. I didn't know. So they were looking, they were already converting their experienced hands and also recruiting decommission people with experience in decommissioning, both legal and well operations and several other teams, putting it together. But we are still sweating, trying to produce some asset, and then we go for some review. We'll say, okay, this well, no, let's close it. I mean, what is giving us versus what we are putting. So the effort to the value doesn't make sense. That is the economic limit. So we just leave the well without going further to intervene on it and all of that. And before you know, you are here, and then that becomes what we call the COP, the cessation of production. All right. And then, of course, whoever that is operating the field at this point needs to start planning what we call decommissioning. Now, this is the reason, I'll just mention this for information. This is the reason why the Renaissance Group and the Shell deal have been delayed for a while. The reason is because there had been the question who the fields are already mature. So who is going to bear the cost of the commissioning? Was it taken into account? Even the self-flat bill, who is going to take in bear the cost of the commission, which is now why in the PIA it became necessary that from the start of oil production, you have to set aside some percentage of your revenue in what we call an escrow account. So an escrow account and the operator will own, but they will not withdraw from it. That account is there for decommissioning because somewhere along this timeline, the operatorship might change. Okay, the operatorship might change for that operator to be aware that there is funds, so that in case you need to abandon this field and decommission it, you don't need to worry. And yeah, that becomes a very juicy part for these are all the people, but I want to explain this. Now, the key thing and the key point I want to bring in, sorry that I think we will just end here for the moment. The key thing I want to point to us is that we all here are technical people, but we must take note of this thing, tech up. Tech up. So tech up is technical, economical, commercial, operational, and political. Okay? So you ask yourself, why is it that? Because sometimes we, the technical people, we think that we are the ones doing the work. But we don't know that also we need to work closely with the economic guys to even justify it. And when we work with the economics guys who justify it, we need the commercial guys because these commercial guys are the guys that breaks the deal. They are the guys that are making deals to happen. For example, the technical person might not know why they are drilling a new gas well, or they are into a campaign to drill like 5 gas wells without knowing that NLNG has provided millions of US dollars to them in contracts because of 27. NLNG has given them money or a guarantee that look, we need this amount of gas from you. Please go ahead, since your field has potential for gas, you have gas, go ahead and drill wells. Give us about, let's say, about 100 million scoff, all right, per day. Give it to us as feedstock. And then the technical guys are basically there to design the assets in design, pass to the well engineering. The well engineering takes it, go to the field and drill the well and all of that. They think they're the ones doing the job. They don't know that these commercial guys are the ones having meetings with those people, bringing the money. And then also, you are looking at these other guys, the operation guys, don't joke with them. They are the ones in the field also that are basically doing a lot of the dirty works. And then also you're looking at these political guys. You don't know what the reason why your company has an office in Abuja. These guys are the guys that ensures that when you are drilling any well, if you are drilling two wells, possibly three boreholes will be drilled in Bauchi, one borehole will be drilled in Borno, in Metubiri, and two boreholes will be drilled in Adamawa. All right, and the cost of all of these boreholes will be tied to these two wells that you are drilling. The reason is because they want to keep good faith. They want to keep good faith. They want to ensure that their license, nothing touch it. They want to ensure that, yeah, they have very good relationship with stakeholders, all right, who can impact on their license so that in case they have any issue, they have people to run to. So you see that the EMP business cuts across a lot of people are involved, the legal people are involved. So by the time you look at it under the pestle, under what we call the pestle analysis, that's the one that now brings in the legal. You look at the legal folks, they come in there. And then also under the pestle, you look at the environmental. So the environmental guys comes in. Now that ESG is becoming a boss, the environmental guys also comes in. So guys, I think at this point, I want to stop here. Let's take question. I won't go into the integrated production system right now. Let's take question. If there are any question, we can take the question. Sorry, I've actually gone beyond our time. If there are any question, let's take it. It's good that today's weekend. Okay, so I think at this point I'll just keep quiet and then pass the mic to Eko Opara. Praise, please.
Okay, thank you so much, sir. And I must comment that it has been an insightful one. You are learning and you are taking notes. I'm sure that we are taking notes. And I know some might have some questions. So please, at this point, within the next 2 minutes, please, if you have okay, so if you have questions, try and indicate because this will be the time for you to ask your question. Okay, so while we are still waiting for that, I just want to like put up a question that one of us just messaged to me. So let me take the question. The person said, "What guides the decision of converting an appraiser well into development?" So the person I think must have asked that question because of what he or she has seen. So what guides the decision of converting an appraiser well into development?
All right, thank you so much. So there are several factors, several factors. All right, the key factors that drives it is first the subsurface location of that reservoir. Now, I was very careful not to say the surface location because surface location really will not matter as much as the subsurface. All right, that appraisal well, is it in a location that is optimal enough to produce hydrocarbon? All right, the hydrocarbon of interest. Yes, is it in a very good location? Now, this is a snag. If the field that we are studying, if it is a field that has been appraised, maybe yeah, like one of the projects I worked on, the field was appraised by then the health company, and they left it because it was marginal. But right now, other companies, marginal companies, are seeing that field to be lucrative. So back in the 70s, so you can imagine how many years. So you might say, okay, this well is in a location. Let's assume that you have a structure. You have a structure like this, and these are appraisal well that we are looking at. So let's assume this is our OWC, which will be our OWC, and this appraisal well is somewhere here. Okay, it's somewhere here. So it did not see oil. Did not see oil, but it helps us to know that, yeah, that there is nothing here, basically. And then someone starts thinking about, is it not possible in development? Can't we use this well and then we sidetrack it? Okay, so we do it as a sidetrack. Now, another person will be correct to say sidetracking a well is almost as good as drilling a new well. Yeah, it's almost as good as drilling a new well, and that can be that can be justified. That can be justified. But I know some of us here we will be thinking about won't we be saving the cost of running casings into the well? Wouldn't we just be maybe sidetracking from a depth that is deep enough, and then via a whip store we locate this other sand at the juicy spot, and then we start producing and all of that? Won't it shorten the drilling time? But because this well is already an old well, it comes with a lot of risk when you are trying to sidetrack it. And then someone else will justify it that it is even better to drill a new well and forgo this particular well. That even in the future, this well might be used as a water dumper. Okay? By the time they start discussing in that feasibility study things that have to do with produced water management, all right, PWM, by the time they start discussing it, all right, so that they can basically meet the EGAPSIN requirement. Yeah, the EGAPSIN. Let me see if I can write that. So this EGAPSIN is environmental um, EGAPSIN, EGAPSIN, environmental, it has to do with the Ministry of Environment. Yeah, the Ministry of Environment. I think if I can find the acronym, but yeah, it needs to meet their regulation, the turbidity unit of the water. All right, it needs to meet the turbidity unit. So it's like a policy, a framework or standard that has been put together for the petroleum industry by Ministry of Environment, and it's there. It's different from EIA. And then by the time you now start working towards it, you find out that okay, this well, you can even use it as a water dumper. So the produced water that we are going to have, we can even dump it into this well, back into the aquifer and all of that. So yeah, I've just mentioned the two key reasons. Number one, the age of the well, the cost of sidetracking, the risk of sidetracking, and the fact that the well might not be structurally located to optimally produce hydrocarbon. Yeah, those are reasons why oftentimes we might basically forgo the well. There's also a very unique one where the well cannot be located on the seabed. All right, because sometimes we believe that because we know the x and y coordinates, the surface x and y coordinates of every well, that by the time we go to the seabed, we can be able to locate 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 the wells. But we've seen this was not identified. They could not find it, and the reason was clear because when they drilled it, they capped it, and after capping the well was drilled without completing. All right, so they capped it, and possibly seabed material scarring effect might have actually moved sand and seabed material over the surface of the well and buried the well deeply such that when they sent in a diving crew, they could not locate, but they were able to locate other wells, but they could not tag that particular well. And then that became a case to basically abandon the well, which means in the FTP, that well was not taken into account because the client has already ruled it out. The company have marked it that this well, they don't know where it is. Yeah. So that is it. Thank you. Praise over to you, please.
Okay, so thank you so much for that explanation. I believe that should be clear for us or for the person that asked. Then another question that just came in, more like a comment or suggestion. The person said, "Sir, please, the explanation seemed to be a little advanced for me. Moving forward, is there a way we can be making recommendation of topics to read and uh, materials to read ahead of the class?" So I think that one should be like the next thing to take into account.
All right. Thank you so much. So, of course, in this class, we are going to have um, we are going to have moments where definitely we'll do paper review. All right, do paper review. That paper review is like they are like mini research. Okay, when each and every one of us will be put in group, and we are going to review papers. They are come up with what I mean our gain from reading those papers, and yeah, some of these things we are going to see them. So thank you so much, and thanks for raising that. Also, the air gap thing, I just checked it now because, but you must know what it really means or what is the environmental guideline and standards for petroleum industry in Nigeria. So I remember I have a friend that went for an interview, and then that interview is for PTO, and this question was thrown at him, and yeah, that he should discuss the standards that guides what to produce water disposal, and he struggled. He said he couldn't. So I think these are just mini information for us, mini information for us, because the water you are producing, you are not just going to dispose it. Yeah, you are not just going to dispose it. It is not water that is coming out of your borehole. These are water that has to be treated to a particular extent because they are water coming out of separators and they are not coming clean. They are water that still have some amount of oil and cream in them. So you are going to treat them to a particular level before you can dispose them. And some companies, what they do is that they leave the disposal, the treatment and disposal to a third party. So they keep producing, they are only concerned with production. That's why when we looked at this, companies have different models for handling this facility. Remember, I mentioned the crude handling agreement. Some companies might also say, look, when it comes to our produced water, we are going to have a three phase, let me use three-phase separator, which means that if you have a three-phase separator, you are going to have oil, gas, and water come out of it. And then when we have water from it, we are going to store that water in a storage tank, and every 72 hours or 3 days, another company or vendor that we have contracted will come with a truck because we are operating onshore. They will come with a truck and they will evacuate the tank so that we don't have any constraint. Because if they don't come and evacuate the tank, then we need to shut down production. So they will come and evacuate the tank. They will take the water from us, free up our tank. Now they have signed agreements and they are known that they are going to go and treat the water, dispose it in a proper way as guided by ECAPSIN and the Ministry of Environment, and we are not going to be in any problem. So yeah, they take that challenge out of their hands completely. Then there are situations where a company might not have this same three-phase. They might have a two-phase separator, which means that that two-phase is only giving them gas and liquid. And at the end of the day, what they have is liquid, which is oil and water in it. So if they are in a crude handling agreement, they will have to send in this liquid into the pipeline of the third party, which means that they have to pay for penalty. So there will be LAT units, which is a lead automatic custody transfer, LACT. There will be LAT units that will be that has been calibrated for custody transfer, and that LAT unit is going to measure, all right, the amount of water, the PS and W, and they are going to penalize. They are going to be penalized for injecting water into the pipeline. Please let's take I see someone's hand is raised. Over to you, PK, please.
Oh, okay. So, thank you so much for that, Mr. Endurance. You can go ahead and ask your question.
representation. So, and then the other one will be likely a plea, not really a question. So for the first one, I saw a diagram on plateau period. So I want to ask, in reality, are there activities we can do? Because definitely every producer wants to stay on this plateau period. So I want to ask if there's any activities that will be carried out to maintain this plateau period. So maybe if it's for a year, 2 years, so is there any really activities that we can carry out just to increase this period or to stay on this period? And secondly, one I said it, that textbook you mentioned on completion. I don't know if we could get a link to get it as a soft copy because I remember you mentioned you're giving the manuscript. So if there's a link we could get the soft copy to be awesome. Thank you, sir.
All right, thank you so much. Let me answer your first question. The second one we'll discuss it later. So yes, there are activities. So if you're looking at the chart I'm sharing with you, now, I mean, this is a recap, the one recap of all of the tradings I facilitated, and usually I use this to like point people to how production operations work, all right, or how E&P companies think. So you see, what they are trying to do here is basically they are trying to still ramp up, okay? But if you look at this label, you can see the several activities that they are doing in order to keep and extend and sustain the plateau. So these activities, for some of the well, it will be an NFA, no future ambition, but no further activity or no further work. So NFA or NFW. Please, NFA is not Nigerian Football Association or no future ambition. Please take that out of your head. Please, no further work or no further activity, which means that the operating rate of that well, the condition of that well is optimal. We are happy with it. We are not going to do anything to wells that are operating at that time. So if we stay with those wells, you will see that the production rate is going to decline, right? Yes, you see the production rate will decline, which means that by 2026 thereabouts, we are gone, we are out of the market. So that's where companies now, when you are within that asset team, you need to be thinking on a daily basis. As you are reviewing, having your reviews, we are going to discuss some of these reviews. So what we are going to be doing is that we are going to be coming up with opportunities, review those opportunities and look towards realizing those opportunities. And that will come within fall within what we call our opportunity realization plan. So one of the opportunities will be that there are wells that we need to put on gas lift, all right? Or there are wells on gas lift already that we need to do optimization on. Or there are wells that basically, okay, that one is also here, that basically have valves already or dummy mandrays, gas lift mandrays that we need to go and install live valves on. Okay, so that is one of the activity that we can do. And as you can see here, if we do that, it brings in a marginal amount of oil that you will find here. And then there's also the activity of reopening. So there are some wells that have been shutting in the past. Oh, let's go and reopen those wells. So we're going to follow the well reopening procedures because reopening a new well there is a pattern. Reopening an old well, there is a pattern. So we're going to reopen those wells, and you see it brings in another marginal amount of oil. And then there are some wells also that we review and we see that, okay, these wells, either the perforations are not conductive enough. Okay, we have done our assessments. Maybe we have even tried simulation. Simulation did not work. So which shows that either the perforations are not really within the outside the are not really outside even the cementing, the cement into the formation and not having sufficient conductivity into the formation, or we are faced with a scenario where those perforations are gone and then we need to go and do what we call perforation, reperforation, where we have to shoot back the existing perforation. You have to perforate those existing perforation. Or it could be a case where water has come into our well, and or yeah, we have a well that is in a reservoir, and basically the present oil contact or water has risen. This was the original. This is where water is currently, which means that any well that used to be here and had perforations somewhere here, we start producing high water cut. So we need to go and look for a way to squeeze this perforation. And if there is still scope for a perforation like here, if there's up to 10 feet, we go and perforate 4 or 6 feet in it, taking into account the fact that okay, will the secondary gas cap appear and all of that. So if it's a undersaturated reservoir, then it means that there will be no secondary gas cap. Oops, let's go and take it. And that becomes a perforation. GLVCO, I've explained it. Stimulation, we look for reservoirs that are damaged, all right? That are damaged. That basically you can stimulate with acid, and those acids will dissolve the damaging materials, you dissolve them, and then you pump them back or you swap them back to surface and the well come back into production. It could be also the waxing. So you look for wells that basically are suffering from waxing issues, or you look for wells that have plugs in them, all right, that you need to go and retrieve plugs that have been subsurface plugs that have been set in the wells. Yeah, you look for those wells and you need to go and retrieve those, and so on and so forth. So there are lots of activities. It could even be a zone change. All right, possibly there's another zone somewhere here that this particular well, if it's no longer juicy, we can set the plug somewhere here, and then we come and open the sleeve that is here to start producing the oil that is behind the sleeve. Okay, and when that oil comes, production. So you see the amount of production that this are the activities, and This basically happens during the operate phase. During the operate phase, that's when most of these activities happen, and those that operate mature fields, they do a lot of that. I believe that answers your question, Endurance.
Yes, sir, it does. Thank you so much.
All right, thank you.
All right, thank you so much, sir. The next person will be taking the question will be Daniel Njoko. But before we go straight to that, I just dropped some messages. You want to follow us on YouTube, most importantly at the moment, because some persons are having some network issues, but don't be afraid, we are recording the session. So for each of our classes, we always upload them to our YouTube handle. So what you are meant to do is just to get subscribe and click on the notifications so that once we make any updates, you can always receive it in real time. So let's take the question now from Daniel Njoko. You can go ahead.
Good evening, sir. Please let me quickly apologize. I wasn't able to join the class early enough, so I don't really know if this was already explained. But my question is that I keep hearing the term marginal wells, and I want to clarify what exactly marginal means in petroleum engineering, what it means to have a marginal well.
Okay, no, sorry, I was speaking, not knowing that I'm able. Thank you very much. I think not marginal well you mean, but marginal field. All right, Daniel, I believe that's what you mean. Yeah.
Okay,
So
yes, sir, that's what I mean.
yeah. So let me look for an example that relates to you and to me. All right. Um, for example, You may be able to dispense on a daily basis. On a daily basis, yeah, I think I'm using the word dispense this time, but you may have the leverage, the ability to dispense 1,000 naira, and you will not be affected, you will not think over it on a daily basis. But someone else does not have that ability to do that. Okay. Now the other way around also, there are certain jobs that you will find, you will not find it to be juicy for you, but that is the same job that someone else is praying for on a daily basis. In fact, the person is looking for that salary. Okay, the person is looking for that salary, but to you, when that salary was offered, you decline it. You say no. You say no because you are looking at maybe the amount of effort that you put in versus the value you get out of it. So yeah, in the context of oil and gas, that's what marginal is all about. Okay, that's what it is. So we are looking at the commercial viability of the field, and the company is measuring that in the job. All right, they are looking at the net cash flow that they are going to, the net income, what they are going to get out from that particular field. How much oil is it? Like for example, there are some companies that once a reservoir has a stock of less than 4, they will just say no, we are not developing it because it cannot even pay for the wells that will be drilled. But there are other companies that will say no, if it is 4, please tell us what we can do on that reservoir. They are happy to put money in it. They are happy to put money, and yet these are the oil that other people are looking at, and they are saying no. And usually, these marginal fields contests or words actually came from the IOCs because they are global, they are big, their overhead is high, okay, and their standards are also high. So there will be certain reservoirs that they will encounter, some fields that they will meet. And when they look at the effort it will take them channeling resources to develop the field versus what they are actually targeting in that particular geographical location, or yeah, in that particular country, or the value what they want to get out, just plug the wells that they have drilled there and tag that field to be marginal. But that same field that is marginal, other smaller companies will be happy to operate it. That's what we are talking about. Daniel, I don't know if that's fine.
Yes, sir, I understand. Thank you very much, sir.